Alright, so welcome to my first video. So today we're gonna talk about naming amines. So naming amines is the exact same way as naming amides, except this time instead of putting amide, we put amine. So let's take, for example, something like this. So here we have 1, 2, 3, 4, 5 carbons. So normally that would be pentane. In this case, we cut out the E, and then we put pentamine, and that's literally it. So let's try another example where the amine is in the chain now with another substituent. So because there's a methyl group on the amine, we denote that with N-methyl. Now let's look at our chain. 1, 2, 3, 4, 5 carbons. But since the amine is in this the middle, we have to denote where that is. So N-methyl 2, 2, 3, 4, 5 pentamine, amine. And the 2 simply just shows where the amine is. So now pause the video and do these ones for practice. So hopefully you've done those ones for practice, and now we're going to talk about synthesis. Synthesis of amines. So there are different ways. As you remember from 118A, you have a BR, and then you attack with Na, N3, and azide, DMF, N3, and here, if you reduce this using LiAlH4, followed by an acid workup, you get an amine. Cool? Pretty simple, straightforward. Now the next way is using a nitrile, DMF, TN. Notice here, this adds a carbon. So, again, we use LiAlH4, CH2, NH2. Moving on. So, as you remember, another way to synthesize amines is using Hoffman rearrangement, NaOH, Br2. So here, we delete the double bond and we shift the N over. And that's all that happens. And here, primary amine, primary amine, primary amine. All primary amines because they're bonded to one carbon. Now with LiAlH4, we can use that to make any kind of class of amine. So here, LiAlH4 plus, all we do is delete the carbonyl. We delete the carbonyl, and here we get our amine. Simple. Now you can use this to make any kind of amine. So let's say we have a synthesis question when Aziri asks you something like this. But if you notice here, that's just a tertiary amine. So it's an amine attached to 3 things. So my first step would be adding the amine itself. It's just that group plus a hydrogen. H, N. Now to get here, all I do is reduction, AlH4. And so those are the ways that you've learned from 118A, B, and C. So now we're going to get into something called reductive amination. So now this is where the new stuff starts coming in. amination. All right, so this is a carbonyl compound plus an amine and then we use NABH3CN to get an amine. So let's do an example of this. So an amine needs to be NH3, NH2R, NHR2. So basically, the amine you're using must have one hydrogen. All right, so let's see an example of this. So here, if I use this, a ketone, NH3, and NaH3CN, all you're going to get is the N replaces the carbonyl and you subtract one hydrogen. So N replaces CO, also lose one H. So here, I'm going to draw out some predicted products, pause the video, try it, and see if you get the answer. H3CN, NABH3CN. So pause that, try it, see and see if you get an answer. I'll go over this with you guys in tutoring individually, so don't worry. So our next one is Gabriel synthesis. So we're going to be using this big, bulky compound named thalidomide. Oops, I drew that wrong. N O N H. So here, this proton is very acidic, right here. So we're going to use NaOH, followed by water, then add SN2 substrate, 3, followed by hydrolysis. NaOH, HO, and heat. Cool, so let's take our first step. So after the first step, that N is deprotonated. And because it's deprotonated, it's more nucleophilic. So if we add an I, something like SN2 substrate, this is going to attack. So drawing that compound out. Now, 2, 3 carbons. Now, if you look at this, that is just an amide. 2 amides sandwiched together. So that means if we hydrolyze it, we'll get a free amine. So that turns to O minus plus H2N. That's it. And that's all for today's video. I hope you guys enjoyed that. Let me know if you have any questions. My first video, try my best. Thank you.